Today, we are diving into one of the most important, but maybe not the most glamorous parts of machine learning, getting your data ready. And we're going to do it by putting on our detective hats, because really, before any machine can learn a single thing, someone's got to find the truth hidden in the data.
You've heard this a million times, right? Well, in machine learning, this isn't just a saying, it's the absolute law. If you feed a model messy, junky data, you are absolutely going to get messy, junky results. It really is that simple. The quality of what comes out depends entirely on the quality of what you put in.
And that's someone? That's us. So for this, we're going to treat our data set like a crime scene. Our job is to dust for prints, interrogate the witnesses, the data points, and make sure the story our model tells in the end is the actual truth.
So, let's get started. Every good investigation needs a mission briefing, a clear objective, and our case is about to begin.
Here's the mission, plain and simple. We need to investigate our data set from top to bottom. This isn't just about cleaning things up. No, it's about deeply understanding the clues within the data, the types, the quality, the hidden relationships, so our model doesn't get led down the wrong path.
And this is our case file, the classic AutoMPG dataset. It's a fantastic collection of info about cars from back in the 70s and 80s. Inside, we've got all sorts of attributes, things like miles per gallon, how many cylinders the engine has, its horsepower, and where the car was made. Our first job as data detectives is to get to know this file inside and out.
All right, first things first in any investigation, you gotta line up your suspects and figure out who you're dealing with. In the world of data, that means profiling our variables to understand what they are.
So you can basically split all data into two big buckets. On one side, you've got your qualitative data. This stuff describes qualities or categories. It's the what or who. And on the other side, you've got quantitative data, which is all about the numbers you can actually measure, the how much or how many. Getting this right from the start is absolutely crucial.
Now let's dive a little deeper into that qualitative bucket. First up, we have what's called nominal data. These are just labels, plain and simple. Think about our car's origin. It could be North America, Europe, or Asia. There's no ranking here, right? One isn't better or bigger than the other. They're just different categories.
Next, we have ordinal data. Now, this is also made of labels, but here's the twist. The order actually matters. A perfect example is customer satisfaction. Happy is definitely better than neutral, and neutral is better than unhappy. See? The sequence has real meaning.
And finally, we get to the other side of the fence, our quantitative data. These are the hard numbers, the stuff we can measure. In our data set, a car's weight in pounds or its miles per gallon are perfect examples. These are the values we can do math on. Add them, average them, you name it.
Okay, so we've profiled our suspects. We know what kind of data we have. Now it's time to bring them into the interrogation room. This is where we pull out our statistical tools and start asking the tough questions. First up, we're comparing the mean and the median. Remember, the mean is just the average, while the median is the value smack dab in the middle. Now, look at cylinders or displacement. See how big that deviation is between the mean and the median? That right there, that's a blinking red light. It's telling us that something is pulling our average way off center.
So what's going on here? Why are they so different? This is one of those classic detective moments. An inconsistency like this isn't a mistake in the data. Oh no, it's a clue, a really important one, that's pointing us towards something deeper about how our data is structured.
And to follow that clue, we'll pull out another tool, the box plot. And for cylinders, whoa, that looks weird. The box is totally squashed at the bottom. Why? Well, it turns out that more than half of all the cars in our file are four-cylinder cars. This huge imbalance is exactly what was dragging the mean away from the median. And just like that, case cracked.
Another amazing tool in our detective kit is the histogram. This helps us see the actual shape of our data. Is it a nice balanced bell curve, or is it skewed, leaning way over to one side? Maybe it has multiple peaks. Each of these shapes tells us a very different story about what's really going on under the surface.
Okay, but any good detective will tell you that clues rarely mean much on their own. The real magic happens when you start connecting the dots, building a web of evidence to see that bigger picture.
So let's say you've got two sets of numbers and you want to know if they're related. Well, for that, the scatter plot is your absolute best friend. It's a super simple way to just see if there's a connection, which way it's going, and how strong it is. And wow, check this out. This is basically our investigation board all laid out. With a scatterplot matrix like this, we can spot relationships in an instant. For example, just look at horsepower versus MPG. It's crystal clear. As horsepower goes up, MPG goes down. That's a strong negative correlation and a hugely important insight for any model we're going to build.
But what about our categorical data, our labels? How do we connect those? For that, we use a tool called a cross-tabulation. And look at what this simple table reveals. It's a smoking gun. Every single one of the 103 8-cylinder cars in this entire data set came from North America, not a single one from Europe or Asia. Now that is a massive clue.
All right, we've surveyed the scene, we've interrogated our witnesses, and we've found some powerful connections. Now comes the final critical step, cleaning up the evidence so it's pristine and ready for trial or, in our case, for the model.
So our detective work totally paid off. We found some missing pieces of evidence, missing values, and some suspicious outliers that just don't fit in. You can think of this as contaminated evidence at a crime scene. If we leave it in, it could seriously confuse our model and point it to the wrong conclusion.
So, what do we do about those missing values? Well, we've got a few moves we can make. If there are only a handful, sometimes the easiest thing is to just remove those records entirely. Or we can do something called imputation, where we fill in the blank with the mean or the median. We can even get fancy and use other similar records to estimate what that missing value should be.
And what about those sketching outliers? We've got a toolkit for them too. If it's obviously just a data entry error, we can delete it. Or, just like with missing values, we can replace that extreme number with something more typical, like the mean. Another cool technique is to cap them, which basically just reins in the most extreme values so they don't have an outsized influence on our model.
So here's the big takeaway from all this detective work. Preparing your data isn't just some boring first step. It is the absolute foundation of good machine learning. It's the painstaking investigation that makes sure justice and accurate prediction is served. So the next time you see an AI make a really weird recommendation or a strange decision, you'll know exactly what the first question to ask should be. Yeah,